Okay, here we go. We're going to tackle 2-3 today, finding trig function values with a calculator. Up until this point, we've been focusing on exact function values. If you are asked for an exact function value, you need to use your special angles and the information that you have that way. But what if it's not a special angle? Well, if it's not a special angle, then we are going to have to use our calculator, and we're going to end up with an inexact answer, and we're going to have to round it off. So when we're evaluating trig functions given in degrees, I need to remember that my calculator must be in degree mode. Now that is super, super important. Remember, your degree button is right here. If I, for example, we know that, let's see, what is something we know? We know that the sine function value for a 30-degree angle is 1/2. So if I'm in degree mode and I push sine of a 30 angle, so there's my domain, my input is 30, I get out 1/2, 0.5. That's an exact value and that works. But if I am in radian mode, 30 radians is not the same thing as 30 degrees. So when I'm in radian mode and I do sine of 30, it finds me the sine of 30 radians, which is a negative, inexact, approximated, rounded off value that's negative. So that tells me that wherever 30 radians falls, it's going to be either in quadrant 3 or 4, because my sine function value is negative. And it's a negative 0.988, so it's going to be almost a -1. So 30 radians is going to fall right, whoops, how about this, right down here, somewhere close to 270 degrees. 30 radians is somewhere close to 3 pi halves, because it's almost a -1. So degrees and radians are not the same thing. When you're doing your notation, if you are working in degrees, make sure you put that degree symbol. We've talked about that before. Okay, so let's start with some easy ones. Let's start with the easiest one of all. Let's start with B, not A, but B, cosine of 193.622 degrees. Now, I've been playing with radians, so I need to change it back to degree mode. And I'm going to find cosine of 193.622 degrees. And there we go. Now my instructions are telling me to round to 6 decimal places. Make sure you pay attention to what my math lab says. Depending on the circumstances, you may use what we're going to call significant digits, or you may have to round to a certain number of decimal places. So for this case, I'm rounding to 6 decimal places. 1, 2, 3, 4, 5, 6. This is going to round to 0.871 as my 6th decimal place. Now, because I need 6 decimal places, if that 6th place would be a 0, I need to leave that trailing 0 to make sure I have my 6 decimal places. Okay, now we're going to go back over here. This one, I didn't start with it just because I've got degrees and minutes. I have a tangent function button, so I can plug it in, but I'm going to have to plug it in. I'm going to have to enter it as tangent of 68 plus 43 out of 60 minutes. So I'm going to make sure that I need to enter it correctly. So I'm going to find my tangent of 68 and the calculator is going to do this order of operations correctly for me. 68 plus 43/60 degree. This tangent function value is 2.567074. So a positive 2.567074 when I round to my 6 decimal places. Okay, cosecant. I don't have a cosecant function button on my calculator. Cosecant is not the same thing as sine inverse. Cosecant is the reciprocal function of sine. Sine inverse means I'm finding the inverse function value. So let's go ahead and let's stop and let's talk about these inverse buttons. Sine inverse, cosine inverse, and tangent inverse show up on our calculator. Those are not reciprocal functions. If you remember your inverse functions from college algebra, when I have a function and its inverse, the domain and range switch places. We did our switch and solve to get an inverse function, to find an inverse function. In college algebra, we talked about, for example, f of x equals x squared is a function. F of f inverse of x equals square root of x is the inverse function, f inverse of x. But this inverse function button, this inverse function, this -1 in my exponent means inverse function. That reflected this parabola over that line y equals x. The domain and the range switched places. Inverse and reciprocal functions are not the same thing. Inverse function means that I am plugging in a function value and I'm getting out the measure of an angle that has that function value. Inverse functions, therefore, the input is the function value and the output is the angle. So for example, if I found, we started out by finding cosine of 30 degrees. Well, we found sine of 30, didn't we? We found sine of 30 degrees. Sine of 30 is 0.5. If I find sine inverse, second function sine inverse of 0.5, that gives me a 30-degree angle. So I'm switching out my domain and range. Now I'm plugging in the function value and I'm getting out the angle value. That is not the same thing. Those three buttons do not give us cosecant, secant, and cotangent. Inverse functions are not reciprocal functions. So I have to be more clever than just pushing a button on a calculator in order to find my reciprocal function values. The reciprocal function of cosecant is sine. So if I rewrite this as the reciprocal of all of that, so instead of taking the function and putting that inverse notation on my function, if I look at taking the reciprocal of this cosecant value, where I'm plugging in the angle, whoops, that degree should be inside my parentheses, where I'm plugging in the angle, I'm getting out a function value. I'm looking at finding this function value and taking the reciprocal of it. Another way to write that would be to write 1 over sine of that same angle. So I find the reciprocal of that value. So I can do this a couple of different ways with input into my calculator. I can do 1 divided by, and then I can plug this in, or I can find sine of this angle value, and then I can take the reciprocal of that. Totally up to you. I tend to do it that way. I tend to say, well, no, let's do it this way. Let's do 1 divided by. Now, when I do 1 divided by, I'm going to go ahead and put my denominator in parentheses. Sine of, I didn't put my denominator in parentheses. Let's try again. Denominator in parentheses, sine of 35.8471. Close out both those sets of parentheses. And I get a sine function value of about, or cosecant function value, excuse me, of about 1.7, and then I'm going to round that to 6 decimal places, 1.707570, and then here things get interesting, right? 1, 2, 3, 4, 5, 6, oh no, we're still fine. That should be rounding to that 6th decimal place. No, it shouldn't. I messed up my decimal places right there. Okay, so yeah, this gets interesting. I was talking and writing and I messed up the writing part. So that is what's on my calculator right here. 1.7075797. So 1, 2, 3, 4, 5, this is where I want to round to. If I look to the right, it's 5 or greater, so I'm going to round up, so I add 1. Well, 9 and 1 is 10, which means that carries over here, and I get 1.70758, but that's only 5 decimal places. I have to put that trailing 0 to have my 6th decimal place represented. Okay, following the logic, what's my reciprocal of secant? Well, it's cosine. So I'm going to do 1 over the cosine of a negative 287 degrees. And I need to see what that is approximately. So I'm going to do it the other way in my calculator this time. I'm going to do cosine of a negative 287. So cosine, I make sure I'm in degree mode, cosine of a negative 287. Now notice that the negative button is not the same as the subtraction button. Here's my negative button down here. So cosine of a negative 287 degrees is this value. That's a valid cosine function output. It's between negative 1 and 1. Now if I take the reciprocal of that, if I do 1 divided by, and then I'm going to use my second answer button, I'm going to let my calculator do the work and bring all that back up. So second answer, that brings me that 0.2 value that my cosine value was. There is the secant value of this function. Remember, cosine and sine are that middle between negative 1 and 1. The reciprocal of that, I flip those open and I'm looking at the ends. So that's a valid secant function value. So I've got 3. Oh, I did it again. Let's see, 3.420304 when I round correctly. And make sure you round correctly because my math lab will count it off. I will count parts of points off if you aren't rounding correctly. Okay, so there is that secant function value. I stuck this one in here because this is important to make sure that you understand what we're doing. We have the sine of a negative 49 degrees 12 minutes. Now I want you to plug that into your calculator and find the answer. The answer should come out to be this, but that may not be what you get. So give it a shot and see if this is what you get. Now, if you did it right, kudos, great job. But if you didn't, this is probably what happened. When you do sine of this angle, it is, all of this is negative, right? This is bigger, more negative than 49 degrees. It's negative 49 with a negative 12 minutes. So that is a negative 49 plus 12 out of 60. So it's this. This whole thing is negative. If you didn't do parentheses, what you entered into your calculator was a negative 49 and a positive 12 minutes. So you did a positive 12 over 60. This is not right. It's a negative 49 and a negative 12 out of 60, so because that negative needs to distribute through. Both of those values are negative. So make sure you can plug that into your calculator and get the right answer out. And then remember how we did our secant function value. We said, okay, this is a reciprocal function, so I need to think of the reciprocal as 1 over that angle. And a little reinforcement to that on our identity sheet where we have our reciprocal function identities here. Secant is 1 over cosine. That will help you remember how to find those function values. That should come out to be about a negative 7.205879. All right. Nearly asked you if you had any questions. That's my problem with doing these things by myself online. Okay. Now we are using inverse trig functions to find the angle. That's the purpose for my inverse function button. If I'm finding the inverse function, I'm finding the angle given a function value. So my domain and range have switched places. Now I know the value of cosine. I need to know the value of theta. So I'm going to be using cosine inverse of this value and it's going to give me the angle theta. So I'm going to do my second function button over cosine. So, whoops, let me clear that out. Second cosine, that gives me cosine inverse. And I'm very carefully going to plug in the angle measure that I was given, or not the angle measure, excuse me. Oh, that was a misspeak. The function value, the cosine function value. I'm in degrees. I get out an angle measure. I didn't tell you a different number of decimals, so we're going to go ahead and round to 6 decimal places again. If I round to 6 decimal places here, that is 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. So yeah, drop it off at that 9. So theta is about 22.899999. 1, 2, 3, 4, 5, 6 degrees. That is the angle that has that cosine function value. Now for cotangent, I want you to think this through. When we were using our calculator to find the function value, we took the reciprocal of the function, so 1 over the whole thing given that angle. Now we're working backwards the other way. I have the function value, so my reciprocal for cotangent is tangent, but whatever theta is, tangent of theta is going to be the reciprocal of this value. So instead of doing the reciprocal of the whole thing, I do 1 over that function value. So cotangent theta is this. That means tangent theta is 1 over all of that. So when I use my calculator, I'm plugging this in as tangent inverse, as my input into tangent inverse. And it's going to give me out an angle theta in degrees because I'm in degree mode. So tangent inverse of 1 over 1 divided by and I get out 1, 2, 3, 4, 5, 6. I'm going to leave 2 zeros at the end of that. 34.654300 degrees, assuming I still want 6 decimal places. All right, excellent. Okay, application problem time. Now, we don't have grade resistance problems much in Texas, at least not where I'm from, but we lived in West Virginia for a while, and we had mountains all over the place, and there would be grades on the inclines on the mountains for the semis, and there would be kind of escape routes up the mountain so that if their brakes burned out, they'd have a safe place to slow themselves down. Now we're given a function for these, and the function that we're given is here, where my force, F, in pounds is the grade resistance, and it's modeled by this equation where W is the weight of the vehicle and theta is the grade. So if it's an increasing grade, theta is greater than 0, so it's a positive value. If it's a decreasing grade, if we're going down, theta is a negative value. So what is going to be the force due to gravity, that grade resistance, for a 5,500 pound car traveling uphill, so I have a positive grade of 3.9 degrees. Well, we're just going to plug it into our equation. Our force, our grade resistance, is the weight of the car times sine of theta. So it says our car is 5,500 pounds, and our grade is 3.9 degrees. And I'm going to need to round that to the nearest 10 pounds. So when I plug that into my calculator, I'm going to get something like this, but I need to round it to the nearest 10 pounds. So I round it to 370 pounds of grade resistance. Let's look at the next one. Calculate F for a 2,800 pound car. It's traveling downhill this time at a grade of negative 4.8. We're still just plugging into our calculator into our function. So if I'm going to, I'll go ahead and show you this one. 2,800 pounds times the sine of a negative 4.8, and I'm in degrees. Always get the habit of checking your mode. So my grade resistance is negative 234 point something something, but I know I need to round it to the nearest 10 pounds. When I round that to the nearest 10 pounds, it rounds to negative 230 pounds. Now, does this make sense? Well, think about it. If you're going uphill, gravity is resisting you. It's pushing against you. So we have positive force pushing against us. If we're going downhill, though, we're moving with gravity. And so that weight of the vehicle gets to roll along, and gravity actually helps us down. So the resistance ends up being negative because it helps us along going downhill. All right, let's look at C. We've got a 2,400 pound car traveling uphill with a grade resistance of 288 pounds. What is the angle of the grade? Well, this time we're plugging in a different piece. We're looking for something else. So this is our equation still. Now I'm given the resistance. I'm given the force, so that's my 288 here. The weight of the car is 2,400 pounds, and I'm looking for that angle of the grade, theta. Let's simplify as much as we can. So I have that sine of theta is going to be equal to 288 over 2,400. I'm looking for theta. That means I'm finding the inverse function value. I know the sine function value. I'm looking for the angle. So I'm going to use sine inverse, plug in my function value, and that's going to give me my angle theta. Let's go ahead and just round it to 2 decimal places. So if I do, sine inverse of 288 divided by 2,400, I get 2 decimal places. I get theta is 6.89 degrees. That's my angle. I'm going uphill at a 6, almost 7 degree angle. That's my grade resistance. Okay, a couple more of these. We're going to calculate force for a nearest 10 pounds for a 2,500 pound car moving uphill. So that's my angle, my grade. I'm going to kind of work through these. I encourage you to pause the video and then come in and check and make sure you got the right value. Make sure you're paying attention to rounding instructions. Notice that I am rounding appropriately and I'm giving my units. Force is being measured in pounds here. Now, F is a little bit different situation. It's a thinking question. You're going to have some of these thinking questions as we move through. I'm going to want you to be able to tell me your reasoning and whether or not it makes sense and back it up with mathematics. If we calculate our force for an incline of 0 degrees and then for 90 degrees. So let's start with grade resistance at 0 degrees. Well, if I'm at 0 degrees, road's flat, right? So do you think that there will be any extra force resisting me? My gravity is pushing down. It's not pushing backward against a grade. So I'm going to say no, that I don't think there's going to be anything extra. So let's just pick a weight of my car. The weight can be anything. In fact, I'm just going to leave it as W for weight. What is sine of 0? Well, 0 degrees is right here. Sine function value here at 0 degrees is 0. And anything times 0 is 0. So there's no resistance. If I'm traveling along, no grade resistance, not any resistance. There's friction, there's regular gravity slowing us down, all kinds of things. But there's no grade resistance, no force added on if I'm not at an incline or a decline, if it's just flat. What about if theta is 90 degrees? Well, where is 90 degrees? 90 degrees is here. So basically, if my grade is 90 degrees, I'm taking my car that I can't draw and I'm picking it up. Well, what's going to be my resistance if I'm trying to pick up the car straight up? Well, whatever the weight of the car is times the sine of 90 degrees. What's sine at 90 degrees? Well, at 90 degrees, my sine value is 1. So yeah, the grade resistance there at 90 degrees is literally the weight of the car pressing down against me. So that is what I expected. Hopefully those made sense and you were able to reason through those.